In this video, we're going to evaluate this integral and check the result by computing the derivative. So you want to give this a try? Go ahead, pause the video, and I'll be right back. Okay, in this particular integral, it's just a matter of using a few identities here. We know that tangent is sine of x over cosine. And because it's tangent squared, this will be sine squared and cosine squared here. And that's over secant squared. But secant is the reciprocal of cosine, so secant is the same thing as 1 over cosine. This will be squared then. And we've got a dx here. Multiply the denominator and the numerator by cosine squared of x. This cancels out here, this cancels out here, this and this cancel. So this is going to equal to the integral of sine squared of x dx. And then we use an identity to reduce this sine squared to the power of 1. And that tells you that if you have sine squared of an angle, it's going to be 1/2, 1 minus cosine of twice whatever the angle is. In this case, it's just x, so this will be 2x. Then it's just a simple integration here. This will be, say, 1/2 here. Integrate inside the brackets there with respect to x. So antiderivative with respect to x of 1 is x. And then the antiderivative of cosine of an angle is sine of the angle. In this case, 2x. And then this, of course, is going to be minus here. The derivative of sine is cosine. And then we have to divide this by the derivative of 2x, which is 2. And we have plus a constant. So this is going to equal to then, multiply through by the 1/2, we get 1/2 x, 1/2 again, times the minus 1/2 sine 2x, so we can get minus 1/4. I've got sine of 2x here, and then it's plus the constant of integration. And this is your answer right there. And then for the check, then, we want to take the derivative of this result right here. So this will be 1/2 x. And then because we have the integrand of the original integral in terms of x, I'm going to rewrite this over here when I compute the derivative. So I'm going to say sine of 2x, there's an identity for that. Here, that's 2 sine x, cosine x. And then the 2 here and the 1/4 reduce, so this will give me a minus 1/2 sine x, cosine x. So we compute the derivative of this, and we want to show that we get this result right here. So let's compute this, distributed the derivative. Derivative of 1/2 x, that's 1/2. We have a minus 1/2 here. So I'm taking the derivative of this right here, but minus 1/2 is a constant, so I'm going to just leave it outside there. And then I use the product rule here. So it's sine of x times the derivative of cosine is minus sine. And then it's a plus here, then it's the cosine times the derivative of sine, which is cosine. And of course the derivative of a constant c is 0. So I'll just leave that out. We get this here. And then we just need to simplify this. So we got 1/2 minus 1/2, and then inside the parentheses we got the sine times the minus sign. This will be minus sine squared x. And then I got a plus cosine times cosine is cosine squared. Cosine squared x. So to get the original integral, first I gotta get this right here. I'm going backwards here, so I need some sine squared only terms. So let's replace the cosine squared here by 1 minus cosine squared. I'm sorry, replace it by 1 minus sine squared of x. That, of course, comes from the fundamental identity cosine squared plus sine squared is equal to 1. So solving cosine squared for this expression here, we can get this in terms of sine squared. So then we have minus sine squared, and minus sine squared is minus 2 sine squared. Of course, I still got the plus 1 there. Then what do we have left? Multiply minus 1/2 through the parentheses here will give us 1 sine squared. Sine squared x. And then the minus 1/2 times the 1 is minus 1/2, but then we have a plus 1/2 here, so that cancels out. So we get sine squared x, which gets rid of this one right here. And of course, to get to the original one, we say, okay, we reduced it down. We took the derivative and reduced it to sine squared of x. We want to get tangent squared. Well, I just divide through by cosine squared. That's legal, as long as I multiply also by cosine squared. So I'm just multiplying sine squared of x by cosine squared over cosine squared. That's 1. So it doesn't change it. So obviously this part right here is your tangent squared, and cosine squared of x, this is the same thing as 1 over secant squared of x. So this gives me tangent squared x over secant squared x, and that's the check for this one. Thanks for watching. We'll see you next time.